This is section 4.5 on 2 more ways to prove triangles congruent. So previously we've had 3 ways to show that triangles are congruent. Side, 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 which means we need to show all 3 pairs of sides are congruent. Side, angle, side, which means we have 2 pairs of sides congruent and the included pair of angles, meaning the angles between the 2 pairs of sides, are congruent. And angle, side, angle, which means we need 2 pairs of angles and the included pair of sides, so the sides between the 2 angles that we have. In this section we have 2 more ways to show that triangles are congruent. The first way works for any triangles. The second way will only work for one set of triangles. So here's the first way. Angle, angle, side. This is a theorem, which means we can prove it directly from one of those 3 postulates we had. Side, 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 angle, side, or angle, side, angle. So we don't need to assume that this one is true. We can prove it. And we might do that in class. It says if 2 angles and a not included side of one triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent. So like with angle, side, angle, we have 2 pairs of angles and 1 pair of sides, but this time that pair of sides does not need to be between the 2 pairs of angles. It can be either of the other 2 sides. So in triangle ABC, I know angle B is congruent to angle E of triangle DEF. And angle C is congruent to angle F, and side AC is congruent to side DF. So I have 1 pair of angles, a second pair of angles, and 1 pair of sides, and that pair of sides does not have to be included, meaning between those 2 pairs of angles. So I know these 2 triangles are congruent, and I can say triangle ABC is congruent to triangle DEF by the angle, angle, side theorem. Now let's think about why this works. I said we could prove it from one of the other postulates we have, and I think it most directly follows from the angle, side, angle postulate, because the triangles only have 3 angles, right? If we know 2 pairs are congruent, then it makes sense that the 3rd pair is also congruent, because they all add up to 180. So if angle B plus angle C plus angle A equals 180, and angle E plus angle F plus angle D equals 180, each triangle adds up to 180. Well, if angle B is the same as angle E, and angle C is the same as angle F, then angle A and angle D are going to have to be the same as well. And we could algebraically show that by setting these 2 equations equal to each other and subtracting off angle B and angle E, and angle C and angle F, and just getting angle A equals angle D. That means, on my triangles up here, I have this 3rd pair of angles congruent, and thus I have angle, side, angle over here. So that's why angle, angle, side works, because we can prove it directly from the angle, side, angle, the ASA postulate. The other way of proving that 2 triangles are congruent only works for right triangles. So, some terminology. In a right triangle, the side opposite the right angle is called the hypotenuse, and the other 2 sides, the sides adjacent to the right angle, the 2 sides that make up the right angle, are called the legs. So this is called the HL theorem. What do you think H stands for? Hypotenuse! Correct. And what do you think the L stands for? Leg! Oh, you're so smart. So this is the hypotenuse leg theorem. If the hypotenuse and a leg of one right triangle are congruent to the corresponding parts of another right triangle, so the hypotenuse and a leg of another right triangle, then the triangles are congruent. So I have 2 right triangles here. Angle N and angle Y are the 2 right angles, and I know that MO is congruent to KE, and ON is congruent to EY. So I have the hypotenuse is congruent, because MO is congruent to KE, and And I have one pair of legs congruent, because ON is congruent to EY. In a right triangle, that's all I need to be able to say that the triangles are congruent. I can say triangle MON is congruent to triangle KEY. That obviously only works for right triangles because only right triangles have a hypotenuse. You'll notice this is the only case in which side-side angle works. It only works for right triangles, and we call it, instead of calling it side-side angle, we call it just hypotenuse leg. Here are two examples. Do we know the triangles are congruent? And if we know them, we're going to name them. And I forgot to name these triangles over here, so let me do that really quickly. Okay, so number one. Do we know those two triangles are congruent? Well, we have a pair of right angles, and we have one pair of sides. So those are two right triangles. We have their hypotenuses are congruent, but we don't know any pair of legs are congruent. So we can't use hypotenuse leg. But we also know that we have vertical angles. So angle TCI is congruent to the angle GCE. So what we actually have are two pairs of angles and one pair of sides, where that pair of sides is not between the two pairs of angles. So this is a case of angle, angle, side. We can say triangle TIC is congruent to triangle. What corresponds with T? It's angle G. What corresponds with I? That's our right angle E. And then C corresponds with itself. The triangle TIC is congruent to triangle GEC. And what about number two on the right? Do we know those triangles are congruent? We have angle A is congruent to angle E, angle B is congruent to angle F, and angle C is congruent to angle G because they're both right angles. Well, we don't know any pairs of sides. Notice in all 5 ways that we have for proving triangles congruent, we need to know at least one pair of sides. We still don't have an angle, angle, angle theorem or postulate, and we're never going to have one. So no, we cannot make a conclusion. No conclusion. These triangles may or may not be congruent. We don't know. So going back up to our list of ways to prove triangles congruent, we have side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg only for right triangles. And here are your immediate practice problems. Are the two triangles congruent? If they are, name them. So say triangle so-and-so is congruent to triangle so-and-so, and state why. Either side, 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 angle, side, angle, 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 side, or hypotenuse leg. If they're not, write no conclusion. So number one, you know angle I and angle E are both right angles. MI is congruent to ET, and MS is congruent to RT. Do you know those triangles are congruent? Number two, angle A is congruent to angle R, angle H is congruent to angle E, SH is congruent to VE. Do you know those two triangles are congruent? If so, name them and give me a reason why. That is the end of section 4.5.